My name is Deji Akomolafe. I'm a staff solutions architect at VMware. I am the practice lead for everything Microsoft application virtualization on vSphere. And it's my mission today to help you avoid the common pitfalls for virtualizing domain controllers in your Active Directory, your forest, your trees, everything on vSphere. Thank you.
Thanks, Ed. Thanks, Deji. Good morning, everybody. Matt Leibowitz. I'm with Dell EMC Services. I'm the global lead for our cloud and virtualization team within our services organization. Thanks for coming. I think we've got a fun presentation today. We're going to do several live demos over the water to a lab in the United States. So everyone, please cross your fingers for us.
And pray.
All right, let's get started. The usual disclaimer, we're not going to be talking about anything that's futures in this session, but just in case. And then we've got a bunch to cover here, which I'm not going to leave this on because we're probably going to run out of time anyway. All right, Deji, go ahead.
When Matt and I started doing this a couple of years ago, we thought about teaching Active Directory basics. We quickly discovered that most of the people in the audience are smarter than we are when it comes to Active Directory. So we stopped teaching Active Directory. So this is not an Active Directory class. What we are trying to do here today is help you understand how to virtualize your domain controllers in such a way that, well, you don't start looking for your resumes. Okay?
Here. Wrong clicker. We've got multiple clickers here.
Okay, we are going to go through some basics of Active Directory, and no, we are not trying to insult your intelligence. Because we have some demos, and we have to present the background for these demos and pre-stage them so you understand why we are doing what we are doing as we go through this presentation. So we are going to go quickly through some very basic high-level of Active Directory concept and constructs. And if you follow me, which is very hard to do, you will understand why we start this way. Okay, back in the days when we started doing Active Directory way back, there used to be a trick question where we ask you, which of your domain controller is the most important domain controller? I'm going to ask you the same question. And please let me know if you want to answer it. Which of your domain controllers, which of your VMware role orders, operations master, is the most important in your enterprise? Anybody wants to take a guess? No. Active Directory domain controllers are all the same. They are interchangeable. There is not one that is more important than the other. They are equally disposable, and they're equally interchangeable. So your PDC emulator, your infrastructure master, your schema master, whatever role order, can go bye-bye. As long as you have another copy, another domain controller, you will survive. So each of them is quite disposable. They are also equal because you can easily transfer or seize roles from one to the other. The only difference would be the read-only domain controllers, which is a little bit special because it cannot perform write origination. The schema update is also a little bit special if you happen to have it on the same infrastructure master. Selective partnership is what domain controllers use in an enterprise to replicate objects among each other. And there is a case for optimal replication for every domain controller, every forest in any enterprise. You want to be sure that changes that happen on one domain controller makes it quickly to the other domain controller and all the other domain controllers in the forest. These changes must converge. If they don't, you have issues, you have problems. Eventually, they must converge. Preferably, you want them to converge as quickly as possible. You do not want to have divergence. There are additional complexity when it comes to multi-domain infrastructure. You have the infrastructure master and the global catalog that usually should not reside on the same domain controller. We'll talk more about this later, and we'll mention some tools for checking your replication topology. By the way, do they get this deck?
I don't know.
Not sure. All right, so we said write can originate from any domain controller. The write or the changes that originate from one domain controller need to make it to the next domain controller. How do they do that? There are multiple ways to do that. These are the guiding principles. Prior to Windows 2012, this is usually the way things are. You have the DSA GUID, Directory Services Agent GUID, which is always unique to a domain controller. No two domain controllers can have the same DSA GUID in an enterprise. They're persistent over the life of the domain controller. As long as you have not rebuilt the domain controller, the DSA GUID remains the same. Please bear that in mind. The DSA GUID is used in update sequence number to track a DC that originates a write. Okay, it's always attached to that DC. Then you have the invocation ID. The invocation ID is used by the DSA to identify the DC's instance of an Active Directory database copy. This can change over time. The invocation ID can change over time. The update sequence number is what we usually call the logical clock. It's used by a domain controller to track changes that happens, whether the one it receives or the one it sends out to somebody else. So the update sequence number increases every time there's a change on any object in the domain. So the domain controller uses the USN, attaches to that change, sends it out and say, I want to replicate this. It gets changes from other domain controllers. It looks at the USN. Please bear this in mind because we're going to be going through some demos that will illustrate this. All right. The USN is also globally unique. No two objects are supposed to have the same USN. Well, we've seen corner cases where that may not be so, but ideally, a USN must be unique in an enterprise, in a forest. Okay, so we take the USN together with the invocation ID. That is what a domain controller considers to be a replicable transaction. This is a change. It has an invocation ID and a USN. I have to send it to another domain controller. Now, what about timestamp? What do we use timestamp for in AD replication? It's not so much important. It's used for conflict resolution. For example, if changes happen on the same object at the same time, the same millisecond or microsecond, then we look at timestamp. The stamp is always the version of that object and the originating time together with the originating DSA over there. That's what determines who wins or which change is persisted and which change is discarded. Okay. We are going to come back to all of that later.
Yep, there will be a quiz later, but let's go through some of the why. Why do we want to virtualize Active Directory? Get some of that stuff out of the way so we can get to the fun stuff. Well, first, virtualization is clearly mainstream. I don't think anyone's here saying this is the year I'm going to go to production with virtualization. Most of my customers have virtualization first policies, so this is the standard for all new systems in the environment. Microsoft does a really, really nice job of supporting their applications and their operating systems in a virtual environment, and Active Directory is no different. All of the FSMO roles are supported in a virtual machine. There's no reason not to virtualize just one role or something like that. All of the characteristics of Active Directory domain controllers make them very virtualization friendly. They're not like a SQL server or an Exchange server that require a lot of resources for one server and then maybe some of the other ones don't require a lot. It's low resource utilization and it's multi-master, which makes it really easy to virtualize. If I had to pick an application to virtualize in terms of resources as one of the easiest, it would be a domain controller. Like we said, they're also interchangeable. You could move roles around. It makes it easier. If you need to provision a new one, you can just deploy it from a template and re-provision and promote the server to a domain controller. And for me, this is one of the most important ones. When I talk to Dell EMC customers, and we work with them, they're buying servers that have 512 gigs of RAM or more. And although Windows itself can take advantage of that much RAM, the domain controller is not likely to do that. Even the largest domains are not going to consume that much. So if you were to run that on a physical server, it would be a very large waste of money. So let's quickly go through some of the objections that Deji and I have heard over the years. This one is sort of funny, the stolen VMDK. And what this means is an administrator or somebody gets access to either the storage or the ESXi host, and they take the VMDK. And now they have your whole directory database, and they can do what they want with it. That's a problem with backup tapes too, but we actually have a solution for that we're going to cover in a few slides, so put a pin in that and we'll come back to it. Privilege escalation is another one. It was historically thought that your vCenter admins also needed to be domain admins and vice versa. And that is definitely not true. You don't need to be an admin in one to administer the other. We're going to come back to this topic a few times. Enforce the standard role-based access control that's in vCenter and in Windows Active Directory. This one has been debunked several times, and we're going to talk about it even more. Some folks thought, well, I have to just keep one role, my PDC emulator, physical, and everything else can be virtual. That's not the case. It's very easy to transfer a role if you have to, or seize a role if your PDC emulator has gone down and you can't get it back up. Deji and I have had to do that ourselves the night before a session because our domain controllers died. So we know that it works and not difficult. I hope I didn't just tempt the demo gods. It doesn't deviate from standard build processes. In fact, most organizations, virtualization improves their standards by letting them deploy from template and keep things based on their organizational image. And then last, timekeeping in virtual machines is difficult, historically and up to today. And on that point, we agree. That part can be hard. It's not only is it hard, it's especially important for domain controllers. As you heard Deji say, timekeeping is very, very important. And so historically what was recommended years ago was disable time synchronization in the Windows server. So Windows time service is disabled. Use this option to synchronize the guest time with the host, so then the ESXi host becomes authoritative. And then after a while we said that doesn't really work, don't do that. Actually disable that feature, use Windows time inside the guest. Guests, the domain members and controllers sync to the PDC emulator. PDC emulator syncs to an authoritative time source. ESXi syncs to that same source, and everything is good. The problem is that also doesn't work, because even when you do that, which is the right thing to do, so even when you follow the rules, this still happens. When you perform certain operations, time sync still happens within the VMware tools. And the most common ones on here, migrate a virtual machine using vMotion and reboot. So these are Windows servers that need patches. Hopefully you're patching them. They need rebooting. And most organizations, or many, are using DRS to migrate workloads around, so vMotion is happening a lot. So what we want to do now is hop over to our demo lab, everybody crossing their fingers, show you what happens when this goes wrong.
So this is what we call living dangerously, our demos. So please pray for us. There are two VMs here, one here and one here. They're both on very good host. The host has very good time. There's nothing wrong with the host. We are going to perform an operation because they're virtualized. Assume that they are domain controllers. Assume that they are your PDC emulator or your schema master or whatever. We're going to perform an operation. We're going to move this VM. Everybody familiar with vMotion, right? We're going to move these VMs to this host here. And please tell me if you see anything bad on this host. Okay, good. So right here, we have these two VMs.
Yeah, what we'll do now is verify that the time is correct on both of them. So you can see this is, again, the time in California in the United States, so that is correct. And what we'll do now is everything is scripted in our demos to make it easier, so we're just going to kick off a vMotion. It's going to move both of these guests, hang on, before you do it, both of these guests over to that bad ESXi host. Now here's what I recommend. Look at the bottom right-hand corner where the time is. If all goes according to plan, everyone's praying, right? What's going to happen is the time will automatically change. We won't have any control over it. So go ahead. And again, this is applicable to all servers, not just domain controllers. It's just domain controllers in particular are very insensitive to time change.
If you want to see what's happening, I'll
Yep,
show you, but this is very quick. We are not doing anything strange, anything secret.
So you can see in the bottom there already, it's changed to the California time of, December 31st. So we didn't do anything. All we did was a vMotion.
This is just a vMotion operation. And this is why people tell you, don't virtualize your PDC emulator, right? Now, if you notice also, 2 VMs, both of them moved to a bad host. One got the bad time, and the other one is happy.
Let's talk about why. So here's what we'll do. We'll pop back over to our slides. We've got more demos to show you, but let's talk about how do you fix this problem? How do you get around it? Well, there's a couple things you can do. Starting at the ESXi host, your hosts need to have correct time. That's important in case the guests do sync with the host. Hosts need to sync with a correct time source. PDC emulator, because that's the authoritative time source within your domain, you want to know where that server is at all times. So we recommend turn off DRS for that and just pin it to a host or a set of hosts so you always know where it is and it's easy to find. Now, you can do a number of advanced settings in your VMX to disable this functionality altogether. You can set all of these so that this no longer happens on any of these operations. Another easy way to do that, VMware created a nice vRealize orchestrator workflow package that will just enable this on all your VMs across your infrastructure. If you've got folks that are good with PowerShell or you're good with PowerShell, you can also do the same thing with your own script. So again, this is applicable to all servers, not just domain controllers. It's just domain controllers are particularly sensitive to time sync. One new thing with Windows Server 2016, I don't know how many of you are running it yet, but Microsoft has increased the frequency with which it polls for correct time and updates the clock if time is off. So that polling frequency has increased considerably in Windows Server 2016, especially when compared to 2008 or 2012. Now it introduces a small CPU load on the domain controllers because of this, because more frequent polling. And in most scenarios, this doesn't matter. There's a really, really nice, very, very long article on Windows Server 2016 and time. What I will say is this, as part of this article, it says if your server or your domain controller has high CPU utilization, and by high, they classify high as 40%. So if your domain controller, Virtualize, has more CPU utilization than 40%, it won't be able to sync time as frequently, or the additional CPU will cause the clock to drift. So here's your opportunity. If you're not at 2016 yet, and your domain controllers have high utilization, figure out why and address it, because when you go to 2016, it's only going to get worse and your clock could actually suffer for it. All right, so now we're going to spend a little bit of time talking about virtual machine security and encryption. Actually, I think the next one is mine. Sorry, Deji. We're going to quickly touch on this. What's new in Windows Server 2016 and security? There's quite a bit new with Windows Server 2016, but not a heck of a lot applies directly to domain controllers. But there's some security changes in there that I want to make sure you're aware of, because those will apply. The first is Microsoft introduced something called the shielded virtual machine, which allows you to encrypt entire VHD files on Hyper-V. VMware has a solution for that as well. vSphere supports it. Hang on just one slide and we're going to get to that. But this lets you encrypt the virtual machine, so when you saw me earlier talk about the stolen VMDK, it wouldn't matter anymore if they stole it. They wouldn't be able to power it on or look at the data. And then the next is what they call the Windows Defender Device Guard, or virtualization-based security, another Microsoft acronym named VBS, which isn't at all confusing. But essentially what this is it uses the hypervisor, because the hypervisor sees all transactions that are going before the CPU, to protect the kernel and the OS. So it prevents malware from running by only executing code that you deem that you trust. This is supported in the next version of vSphere. We can't demo it now, but the next version of vSphere will support this as well, so you'll be able to use this feature. And if you want to learn more, you can look at that article there.
You remove it?
Yep, and then this is just a screenshot. We weren't able to show you it, so this is what it looks like when it's been enabled. You can see a hypervisor has been detected. Features required by Hyper-V will not. That means we know we're not Hyper-V, but it works on vSphere. And again, stay tuned for the next release of vSphere when this will be supported.
Okay, by the way, you didn't see this. I didn't click that, so this doesn't exist. But
I read the disclaimer slide, so we're good.
If you're wondering if VBS will be supported on vSphere platform, the answer is right there on the screen. Just pretend you didn't see it. All right. We highlighted stolen VMDKs as one of the primary concerns of domain administrators why they don't want to virtualize their domain controllers. Because one of the benefits of virtualization is we make things easy. One of the dangers of virtualization is we make things too easy. Because we turn things into software and files and everything, it's very easy for somebody to, let's take this VMDK, transport it to somewhere else, and now they have your deed. Oh, well, if they have your deed, well, they can then start working on cracking everything, and they have every data that you have. Apart from the features that are coming up, and the VBS that we just mentioned, or the host guardian, VMware proactively actually came up with VM encryption, whole VM encryption, where if you mark a VM as being encrypted, and somebody steals that file, that VMDK, they take it elsewhere, there is nothing they can do with that VMDK. I call this, probably this is the American term, but you know, a thief goes to the bank and steals a bag of money, and in the bag of money is a die, and they open it, boom, it's useless money. So the thief or that steals your VMDK cannot in any way access the data in that VMDK because it is encrypted. This facility is built into 6.5. It requires a KMS, key management system, which you control. VMware does not insert itself into that mechanism. You present any KMS that's compatible with this feature, and then you tell your vCenter, okay, please go and use this KMS to encrypt VMs for me. It's all under your control. We don't insert ourselves in there. What happens is you can have multiple KMS. We actually recommend multiples of them, and you enroll your vCenters in there. Your vCenter gets an encryption key from the KMS, and we use that encryption key to encrypt your VMDKs and other data. Okay, so this is how it works. I'll build this up a little bit quickly. I won't be able to go into details. By the way, there are all sessions dedicated to this feature at VMworld here. We're just highlighting this from the perspective of domain controllers. So please be sure to attend these sessions if you're really interested in this. And you should be, especially since you are here and you probably have one or two things to do with domain security. Please consider attending those sessions. All right, so this is all it's all about. Because we're doing encryption and decryption, of course, yes, there will be some overhead, right? The overhead, I can't tell you exactly how much it is. Again, the experts out there will be able to tell you. What we know for sure is if you want to minimize the overhead, if you have hardwares that support AES, NI capabilities, then the footprints of the encryption and decryption traffic is minimized. So if you're going to do this, buy newer hardware that have these capabilities. A little bit more details in how this works. You supply the KMS. You own it, you operate it. It is this repository, central repository for all your crypto keys. As long as it's KMIP 1.1 compliant, we don't care. And as long as the vendor tests it with vSphere, we don't care. We don't even ask you which one you're using. Please create a cluster of KMS because one, if you have one single KMS and that KMS becomes unavailable, how do you decrypt or re-encrypt data? So if you have a cluster of them, then you have, as in everything, high availability. The vCenter is enrolled in the KMS. We establish trust. It obtains crypto keys, key encryption keys from the KMS. It distributes the key encryption keys to the ESXi host. The ESXi host uses it to generate its own deck, and it uses that for encrypting VM files. I'm going quickly through this. I'll build it up. Now, if a host is enrolled in this facility, and it has the key encryption keys, and it generates its own encryption keys, and uses it to encrypt VMs, it's conceivable that somebody could say, okay, let's take this host, steal the host, and whatever data is in there. Yeah, we thought about that. Once the host, ESX host, leaves this vCenter, the host cannot use that key. If you bring it back to the vCenter, the host key is discarded and it has to obtain the key again. All right? So protection at all layers. The most beautiful thing about this is it's just a right-click encrypt VM, or create a policy, apply the policy to the VM, and you get encryption out of the box. It doesn't cost you anything beyond what you already paid for the licenses. All right. If you take a VM out of this infrastructure, this particular one, even if you have the same KMS for another vCenter area, that VM cannot power on in that other area. So as soon as this VM leaves this environment, it becomes useless. This is why we came up with the die pack security analogy.
All right, good stuff. So we're going to talk now about some best practices for virtualizing domain controllers. One, they're the easy stuff, right? If you have multiple data centers, deploy more than one domain controller, put them at multiple sites. There's no reason to have traffic coming over the wire for that sort of thing. The first domain controller that you deploy in your organization always owns all the FSMA roles. It makes sense. It's the first domain controller in the domain. If you or another administrator has never changed that, that means they all still live there. So go back, take a look, distribute them as necessary. Follow Microsoft's best practices. It doesn't matter whether it's physical or virtual, the best practices still apply. Now, you heard me talk about this earlier, use role-based access control. Again, I'm going to talk about it probably again later. Your vCenter admins don't need to be domain admins, and your domain admins don't need to be vCenter admins. Use role-based access controls to keep them separate. Now, should you P2V a domain controller or not? Does it make sense if you have a physical domain controller and you want to move it virtual, should you P2V it? In our experience, the only reason people P2V domain controllers is when they hate themselves, because it's unnecessarily painful. Now, if you absolutely have to do it, here's the knowledge base article from VMware that describes it. But it is far, far easier to provision a new server, promote it to a domain controller, transfer roles, replicate the database, and decommission the old one. Only do this if you absolutely have to. And then use DRS, use affinity, anti-affinity rules to keep domain controllers separated, and so that you know where the important ones like the PDC emulator live at all times. What about sizing? I talked earlier about how sizing is not that difficult in a domain controller. Well, let's just briefly talk about that. Microsoft's guidance, if you don't know already, 10,000 users, one virtual CPU is fine. Bigger than 10,000, start with 2 and then scale up if needed. If you don't know, look at a physical domain controller, look at its utilization and engage from there. Otherwise, start with 2 and scale up. They're usually not heavy consumers of CPU. Now, memory, domain controllers are like SQL servers in any other database. They take the Active Directory database and they cache it into RAM, and then all subsequent reads from that database come out of RAM, which improves performance. If you don't know whether your domain database is cached in RAM or not, there's a really nice perfmon counter here that you can measure and see how used that is. And if the value is low, that means it's reading from the disk instead of from RAM, and you could potentially get better performance if you add more RAM to the domain controller. For network, it's pretty easy. It's the standard device, VMXNet3. And then for storage, all you need is enough storage for the database, for growth, because you're going to grow your database, and then any additional software. Don't forget about things like antivirus, backup, protection, whatever else you have in there. And then our favorite topic is DNS. Deji, you want to go over DNS? Everyone's favorite topic.
I used to work for a boss, and his mantra every time he comes in to the office is the DNS up? Yes. According to Microsoft's support metrics, most of the problems associated with Active Directory issues trace back to DNS. Okay? AD depends on effective name resolution. If I can't find you, I can't talk to you. If I can't find you by name, actually, I cannot talk to you. Even if I can find you by MAC addresses or IP addresses, doesn't really do much for me as a domain controller. They like to be able to talk to each other. Instead of saying, hey, you, I want to be able to say your name. Internal processes depend on DNS. There is this concept of initial replication that happens in a domain or a forest. When the domain controller comes up, it is required to first be able to talk to another domain controller if it's not the only one in the domain. If there are more than one domain controllers in a domain, when a domain controller comes up, that domain controller must be able to talk to another domain controller before it can start advertising itself as a domain controller. Effectively, if it's not able to talk to somebody else, it becomes an island. The DC cannot start advertising itself as a DC if it cannot start its DNS service, especially if you're using Windows DNS. If it's not able to resolve somebody, a peer, then it cannot function. I'll show you a demonstration of this very shortly. It cannot synchronize with anybody. It is effectively just a server, a dumb server doing nothing. Why did Microsoft do this? It's really to be sure that your environment is sanitized, it's working fine, okay? You can disable this requirement. I seriously recommend that you don't try and do it, or you may do it in an emergency. If everything else fails, you can disable this requirement by setting this registry key. But it is essential for your own safety, for your own security, for your own operational efficiency. Please do not disable it. Here is what it looks like. This is DC1 coming up. And the first thing it does is it initializes its TCP style. What's my IP? Oh, my IP address is, please watch that number, that address, okay? And then it says, okay, where's my DNS? What's my DNS IP? And it says, oh, your DNS service is that IP. Do you see anything funny here? So this domain controller is 10.10.10, and its DNS is 10.10.10, using itself as a DNS server. It is its own client. So please follow me. All right. I am required to sync with my peer. This is 02. Blah, blah, blah. Right? Okay. DNS, could you please tell me where I can find DC2. Blah, blah, blah? Sorry. And DNS says, I don't know because I haven't started yet. And then, okay, you haven't started. What do you mean you haven't started? All right, please start DNS. And DNS comes back and says, you have to talk to DC2 first before I can start. All right, give me DC2. I can't give you DC2 because I haven't started. You understand this concept. Now, what's wrong here? This DC is pointing to itself only and itself only as its DNS server. It can't start its DNS. It can't do the initial replication. So this DC right here is sad. That is a big problem in any Active Directory infrastructure, and it is a common problem we see when people virtualize domain controllers. And they blame the virtualization aspect. I don't want you to do that. Please always remember this. Point your DNS server, your domain controller, to itself to somebody else for synchronization, and to itself as a failback. Is that yours?
Yeah, now go. You can get our next demo ready. Quickly, because we're running short on time here. You know, here's some historical problems with virtualizing domain controllers. Microsoft has most of these addressed. They're really here for historical purposes. Here's the big one, other than time synchronization. Remember we talked about USN earlier, we're going to talk about it again. Each domain controller needs to keep track of its own transactions and the transactions of every other domain controller so it knows who's authoritative, what changes are authoritative, what changes it should accept, et cetera. And it does that via the USN and the invocation ID, which we spoke about earlier. Now, if you have a snapshot on a virtual machine, a virtualized domain controller, and you revert that back, it's going to go back to old USNs because it doesn't know that it's used them already. So here's what will happen. It'll think it's okay. It won't know that something is wrong. It will try to replicate with other domain controllers. Other DCs will say, I've seen these USNs before. I don't want to talk to you. And then it'll become essentially orphaned. So let's talk quickly about why this is bad with a little demo of what this looks like. Just follow me here on the numbers, all right? I've got DC1, DC2, I've got USN 100, invocation ID A. Everything's fine right now. I'm going to create 10 users, I'm going to increment my USNs, and I'm going to replicate that transaction to DC2. DC2 says, I haven't seen these transactions. I'm at 100, you're at 110. I'm going to accept these. That's fine. Now I'm going to be that sneaky administrator, and I'm going to take a snapshot. Right? So now I've taken a snapshot. Still nothing has changed. I'm at 110 here, I'm at 110 there. Everything's fine. I create 10 more users, and my USN has incremented again. I replicate that over to DC2, and DC2 is going to say, I'm fine with that. I haven't seen these transactions before. Where we get into trouble is when you revert that snapshot back. We were at 120, I revert back, now I'm at 110. Again, this DC doesn't know that it's been reverted back. So here's what happens. I'm at 110, he's at 120. I say, I'm going to create 10 more users. I'm going to use these same USNs because I don't know the difference. I'm going to replicate them to DC02. DC02 is going to take one look at this and say, no, I've accepted these before. I'm not accepting them again. You are now orphaned. That domain controller will no longer work in the domain. So what Microsoft has done is introduce some new safety features, which we're going to try to demonstrate for you here. And what it's called is the generation ID, and it's a special attribute that's generated from a driver inside Windows 2012 or 2016 to communicate between the hypervisor and the guest. So VMware Tools is not required as part of this conversation. It's exposed. It needs to be vSphere 5 update 2 or later. I realize that's, most of you are probably there, but just in case, needs to be vSphere 5 update 2 or later. The guest OS needs to be set to Windows Server 2012 or 2016 or it won't work. Even if you have that OS installed, it's still not going to work unless it's configured. And then you can look at the VMX file and actually see the data there. So you're going to see why this is important. That attribute is tracked. It's stored in a local copy of the Active Directory database on each domain controller, and that attribute is not replicated. You'll see why that's important in a second. So what happens is when you revert a snapshot, the virtual machine generation ID changes. And as soon as that happens, the safety feature kicks in that we're going to talk about. Now, it provides two different features. One is safety, one is cloning, but we're going to talk about safety first. Now that allows you to take a virtual machine domain controller that's been either reverted from a snapshot or restored from a backup and put it back into your domain without any issue like we saw before. So it's generated when the virtual machine boots, and it's evaluated before the domain services start, so it knows not to try to replicate if something's happened. So here's essentially what happened, what we're going to try to show you. As soon as this happens, it's going to compare the generation ID to the local copy of that generation ID stored in the database. That's why it's not replicated. If it's different, here's what's going to happen. It's going to dump the RID pool on that domain controller and generate a new invocation ID for the local copy of the database. So what happens is any new changes can be committed and any changes lost will come in. I'm going to quickly show you a demo of that because I know we're short on time, and then we're going to go. We'll show you the real demo. So here we go, same as before. This now I have Gen ID 001, USN 101, invocation ID A. Similar to before. I've taken a snapshot because again, I am a sneaky administrator. I've created user 1, USN 101, replicated over to DC02. DC02 says this is fine, no problems. Now I'm going to revert the snapshot. And here's what happens. Notice this Gen ID has now changed. It's going to communicate with the driver inside the guest and update the copy in the local copy of the Active Directory database. Invocation ID has changed, new Gen ID, but I'm still back to my same USN as before. So I'm going to do the same thing as before. I'm going to create user 2, and I'm going to replicate it over. Same USN, but different invocation ID. Now it says, I accept this transaction. I know the generation ID is kicked in. I recognize you have a new invocation ID. I'm going to accept this. Not only that, I'm going to give you back the one that you missed. Here's the one you missed from between when you did the snapshot creation and revert. In the example I showed previously, the domain controller gets orphaned. In Windows Server 2012 and 2016, you get this. Yay. All right, so let's show you what this looks like for real.
All right, we are going to try, not...
Have some confidence.
All right, switch. All right, so 2 domain controllers, same for us, users in there. What we are going to do is we are going to simulate a rollback because we make things very easy, again, in virtual environment. You can roll back easily. So we are going to
all right, so here's what we got. 2 domain controllers here. We have the same set of users just to show that they're replicating. The domain is healthy. So here's what we're going to do. We're going to create a snapshot on one of these domain controllers. And again, we do everything via scripts. This way, Deji has to type his password in front of 400 people, and he loves doing that.
Oops.
Okay, so once that is created, what we're going to do is make some changes.
Yeah, keep going.
Okay, so yeah.
It takes a while.
Okay, so what we'll do, so here's what we're going to do. We'll create a folder on the desktop so that you can see that when we revert the snapshot, the folder is gone. Then we're going to delete all the users, every single user in the database, and make sure that that replicates over. Then when we revert the snapshot back in Windows Server 20 in 2008 or prior, what would happen is those users would still be there on the reverted snapshot, and that domain controller would essentially become orphaned. What we're going to show is that that's not going to happen because these are Windows Server 2016. So how are we doing on that snapshot?
We're going to create a folder.
Okay.
Folder now.
Again, this is just to show that when we revert the snapshot, that folder should be gone for those of you playing along at home. Okay.
Is it done?
I don't know. Is it done? Oh, so close.
No, not yet.
Oh, no, we're good. All right, so we're good. So now we're going to go into the domain, and we're going to delete every user in there. I would not recommend this, but for the demo, it's Deji's lab, so it doesn't bother me.
It doesn't bother you, right?
Doesn't bother me at all. So go ahead and delete the users.
So whoops, okay, so.
Just, you know what you can do? Just go into the domain and just delete them all.
Please don't do this in your production environment.
It's not recommended. All right, so what we can do is go to the other domain controller and refresh here, and assuming everything goes according to plan, which it appears I might have angered the demo gods, but.
No,
Yeah, all right, so they're all gone. So we're good. So now what we're going to do is create a new user. Do you have the script to either create a new user manually, or we'll issue the script to create a bunch of new ones? Oh, actually, no, don't do that. Let's revert the snapshot. Let's revert the snapshot back. So here's what should happen. All those users should not come back, because when we revert the snapshot, the server should say, hey, I've changed. Here's my latest invocation ID. The other domain controller will say, you have the wrong copy. Here's the latest copy of the database, and all those users should disappear. Now let's hope that the revert snapshot doesn't take as long. If it does, we'll come back. Let's see, how's that doing?
It's doing.
Oh, perfect.
It's just a revert.
That one's easy. Okay, so now, two things. One, that folder should be gone, and two, the user should not be there. That's what we expect to happen. So why don't we check the desktop of, was it 101 that you made the change on?
No, 2. It's not done yet. It will kick me out very soon.
Is that the one we took the snapshot on? This is going great, huh, guys?
Yeah. It's restored. It's restored. The user didn't come back.
Okay, so good. So it restored the snapshot. The users did not come back, which is exactly what we would expect. So we're short on time. Why don't we flip back?
Yeah. Go ahead.
And we'll keep going. And we saw the demo.
No, I create user.
What's that?
I create users.
All right, we'll come back to that. So just because you can do this doesn't mean that you should do this on a regular basis. One, there are reasons why you would want to do this. And the biggest one is if you have to install a piece of software on the guest, the domain controller, just like any other server, you might want to take a snapshot first, test it, and if it has a problem, you could roll it back. Backup software that takes image level backups, those are going to take snapshots. And anytime you restore a backup, it's going to require the safety to kick in or you're going to have issues. But just remember, like everything else, snapshots are not backups. So don't assume a snapshot is a backup. You're probably not going to use this on a regular basis. But if you have Windows Server 2012 or 2016, you're going to be happy to know that it's there if you need it. All right, so now you want to switch over to cloning, or you want to go back to you?
Yeah, let's do.
Here, why don't I do this quickly? I'm going to talk a little bit about cloning while he gets our cloning demo ready.
Two of the features you can use, the most important features for VM generation ID, safety and cloning.
Yep. So while we're working on the safety one, we'll get the cloning one ready. But essentially what it lets you do is clone domain controllers just like you would a regular server within vSphere and have it still operational. And the way you do that is you have to prep the domain controller, the source domain controller. So you have to do a few things on it. First, you have to add it to a group in Active Directory called the Clonable Domain Controllers Group. So the computer object gets added to the group in AD. And then you have to create this file called the dclone config file on the source domain controller. And what that does is it validates that software on the domain controller is supported in cloning. And we'll show you a little bit about what that looks like. Shut down the source DC. Notice how important that is. Your source DC is down for the entire cloning operation. That means don't shut down one with a PDC emulator or any other FSMA role for that matter.
Let me speak to that. Please I don't want to skip over that statement. If you're going to clone domain controllers on vSphere, even with the VM generation ID, please make sure that the domain controller you're cloning is shut down properly. Otherwise, if you clone it, if you don't shut it down properly or you clone it hot, which will let you do hot cloning, what is going to happen is the resultant clone will come up fine. And about 24 hours later, you will be calling Microsoft support because your entire forest will be corrupted. And it's not theoretical. We have a blog on our website that discusses this. Microsoft also has the same thing telling you. We discovered this during our testing. Please do not hot clone your domain controller for any reason.
You heard him. Okay, so same as before. When you power on that domain controller that's been cloned, the same things that are going to happen, just like with safety. It's going to see that the generation ID has changed, so it's going to dump the RID pool, it's going to generate a new invocation ID, but then it's going to look for that DC clone config file, and if it finds it, it's going to kick off the cloning process. Now the nice part about that is that it's going to, you ready to switch over? What it's going to do is it's going to use the existing copy of the Active Directory database that's on the server and the contents of the sysfile directory. So if you have a big database, it won't have to replicate over. It'll start from that and only give you the changes.
This is what the script we're using looks like. It's very trivial. There's nothing really complicated about it. And this is all documented by Microsoft. So we're just going to prepare this domain controller. This is 02, which doesn't have any FSMO role. We're keeping this simple. We're going to just run the script, if it lets me. Okay. So this script is going to go ahead and prepare this domain controller. It's going to add it to the clonable domain controller group, security group. If this DC is not in that group, this DC cannot be cloned. It's a safety feature put in there by Microsoft. Yep. Then it's going to create that bunch of files. Because we don't have a lot of time, we've cheated a little bit. So now, as you can see, that domain controller is shut down before we can then go and start cloning it. So we kind of...
because the cloning process in our lab could take some time, we sort of already did that. We've cloned it, and now we're just going to power it on and show you what that looks like. And we might have to come back to this a few times because this can take a little while. But we wanted to give you an idea of what it looked like. So while you're going to power that on, why don't I talk for a little bit and we'll come back to that.
Let me see the beginning.
Okay.
All right. So this is the clone. It's coming up. What is going to happen is VM generation ID is going to kick in. And it's going to say, oh, you've been cloned. Your VM generation ID has changed. We need to do something. What is going to happen is this guy will now be told to discard the read pool. A domain controller that doesn't have a read pool cannot create security principal. So essentially, it's just a server. So there will be a lot of things going on behind the scene. Please go ahead. And
why don't we? Well, we're going to switch back and forth a few times as this thing's moving. So we talked about this. So let's talk some considerations when you're doing cloning. Well, you heard Deji say the most important was don't do it while the domain controller's on. That's not going to work. The other is don't do it from one that has a FSMO role. Now, in some cases it will work, but the clone will be inoperable. In other cases, it won't work at all. So again, think about the chicken and the egg. Like you could do it with the PDC emulator, but do you want that server to be down during the cloning process? Probably not. You're going to have time problems in the domain. DNS, obviously very important. Okay. So we can see the cloning is happening here. This will take a little bit, so Deji will surprise me and switch back and forth. Let's say you want to do more than one clone. Let's say you want to clone 15 or 20 domain controllers all at one time for whatever reason. Maybe it's...
Which you do every day, right?
Sure. In a lab, just for fun, whatever. You can do that. Now, in the DC clone config file, you normally specify a name for the server and an IP address of the server, but you don't have to do that. You could leave these attributes out, tell it how many that you want, and it will use its own generated name and create as many as you want, as long as obviously DHCP needs to be functional. Same rules apply though. The source domain controller needs to be off. So now if you have to clone, thank you very much. If you have to clone 15 or 20, the source domain controller has to be off the whole time. So it makes it even harder to do in production. Obviously you can't turn it on until it's done. The other thing you can do, which we can't easily show you, but you could prepare the server, you can shut it down, you can clone it, and then you can convert that clone, you can convert it to a template. So then every new provision server from that template is a clone of a domain controller. That will work. The challenge you have is that you have an attribute in Active Directory, the tombstone lifetime, that will eventually expire, and then you can still clone from that template, but they won't actually work. So generally speaking, you're probably only going to do this in certain scenarios, but we wanted to show you that. Last but not least, don't perform guest customization when cloning a domain controller. You're going to sysprep your domain controller. It's not supported. The domain controller doesn't like it, and it's not going to work.
Now, if you don't prepare this domain controller properly, or you don't have a domain controller available to give it the new read pool or to just remediate it, this guy is going to end up in a jailed environment. DSRM, which means we won't allow it to participate in AD. It's another security feature. If you prepare the domain controller, the reference domain controller, and you shut it down, and then you power it back on, you can't clone it anymore after that. It's another safety feature. So before you bring that reference domain controller back up, please just clone it to a template, and then you can reuse that template continuously while that domain controller is back. We're almost done here.
Yeah, we're almost done. We will come back to this. All right, quickly, some general considerations. vSphere 5 Update 2, important. Guest operating system has to be set correctly. Again, I can't say this enough. If you have Windows Server 2016 installed, but you have the guest OS set to Windows Server 2008, you can do everything else right, and none of the stuff we talked about today will work. So always do that. Leave the clonable domain controllers empty. You don't want to accidentally clone a DC, and you want to enforce role-based access control like we talked about. Let your domain admin move the computer object. Let your vCenter admin actually do the cloning operation. This part is required as part of the cloning. VMware Tools is safe, but it's going to validate all of the software that's on there. So if you have an antivirus agent or some sort of security software and it doesn't support it, you're not going to be able to clone it. I don't think anyone here is using Windows backup, but if you're going to do that, obviously you want to delete the backup history once it's cloned. You can't restore from the old backup. And then you heard Deji say DSRM jail. You want to avoid that.
So as you can see over here, now we have a third domain controller properly prepped. It's coming up. This is the last reboot, but now we just clone a live domain controller, and you have really quickly provisioned one without having to do DC promo.
You can see the object is actually
the object is up there. So that is another feature of VM Generation ID. Because we make things easy in the virtual environment, if you had done this in any other Windows version prior to 2012, you would have just corrupted your forest. So VM Generation ID adds another layer of security. I don't say it makes everything safe. It makes it safer than before, because there are still some things that you can do that can still screw up your entire forest. Excuse my French.
All right, I'm going to very quickly go through the last slide, then we're going to talk about disaster recovery.
We don't have time for this.
Okay, well, we'll go through as much as we have time for. The reasons folks didn't virtualize domain controllers, I think in the past, have largely been addressed by either features within vSphere or features that Microsoft has added to domain controllers that vSphere supports. So all the stuff you heard in the past, it's really not an issue. It's 100% supported, and the characteristics make it easy. Low utilization, multi-master, that makes it really easy to virtualize. The best practices you follow in a physical domain controller are the same as those you'd use when virtualized. Sizing, availability, FSMO roles, it's all exactly the same. DNS, security, time, all of that stuff. Again, it's natively highly available, Active Directory, because it's multi-master, but when you add it to a vSphere cluster and it uses HA, you actually get better availability than if it were physical, because not only will it automatically use another domain controller, but that failed DC will automatically restart with HA. So upgrade to Windows Server 2012 or 2016 and you get all the benefits.
Okay. This is probably going to be the last slide. We have more of them, but time constraint. The reason we started with invocation ID, USN, and all the things at the beginning is to bring it back to this. Replication, how they happen, how they converge. Now, we said when you clone or you use VM Generation ID, you restore a domain controller, we said the domain controller loses its identity. It loses its read pool. It's no longer a domain controller, right? So imagine if you have all your domain controllers in your one data center, and then you have a DR situation. A DR situation being a catastrophic failure where everything is down. And maybe you're forward-looking, you have copies in cold storage somewhere, replicated over. And now you go to your DR site and you bring these VMs back. These VMs are being restored from whatever. They're coming up dumb because VM generation ID is going to say you are coming from a backup, right? Which means they come up, they don't have any identity. Nobody there, the read master is not there to give them read pools. Your PDC emulator is not there to help them with anything because they are now just dumb domain controllers. How do you handle that? That is a consideration I like my audience to factor in when they're thinking about the feature and the benefits of VM generation ID, VM generation ID and the feature, the capability that it gives you. Always think about your DR scenario because somebody has to be there to service these new domain controllers that are coming up. I always recommend, please, as part of your DR plan, put a domain controller, a hot domain controller offsite somewhere for DR situation so that if you have all this catastrophic failure, you can seize the FSMO roles over there and then you can recover all the other VMs as long as you have somebody there who can service their read pool need, they will come up. Now, if you don't have anything there, you are going to go through some complicated recovery effort. I put this here for your after-hours reading. There are many ways that you can do this. The easiest one is if you can just run this PowerShell restart services NTDS-force. Just restarting the NTDS service by hand doesn't do it for you. You have to use this PowerShell script to actually get that domain controller to be able to start its services, the services it needs to be able to talk to anybody else. So that's how much we can get into today. I hope it's been beneficial to you. Please go and virtualize. I don't want to say go and clone unless you're in the habit of selling domain controllers every minute, like Amazon. VM generation ID helps you have a safer virtualized domain controller AD forest experience, and it is fully supported by both Microsoft and VMware. Just don't do it hot. Thank you very much.
Yeah, so hold on. So two things. First, fill out your surveys, please.
Yes, I get
much
paid.
Appreciated.
That's how I get paid, please.
Two, if you have questions, there's microphones, I believe, around the room, so don't hesitate to go to them and ask, or come up afterwards.
And we will be here because nobody after us. It's lunchtime, so we will be here if you have questions. Thank you very much.
Thank you very much.
Gracious. We appreciate it.